Indefinite integrals day 2. I'm going to put 15 minutes on the clock. And I think some of you guys just need some more practice with the indefinite integrals, especially the ugly ones. So I'm putting 15 minutes on the clock. And we're just going to get some practice time. For those of you that you're good, work through these problems on your own. And check in with me from time to time. We'll go from there. But I bet most of you guys are probably going to stay with me for some of these. And Giselle, we're filming? Excellent.
Aye.
All right. Number 2, antiderivative of, or indefinite integral of x squared plus 4x over x squared with respect to x. You need to remember when you see multiplication and division in the integrand, bad news. We have no properties, we have no tricks. Actually, take that back. We have no properties, but we have lots of tricks. So, legal stuff. What's the legal thing you could do? Ron Beer, what's a legal thing that you could do?
You can rewrite.
Tell me how you're going to rewrite.
You're going to separate the x squared.
Tell me how you're going to do it.
X squared over x squared
X squared over x squared
plus 4x over x squared.
plus 4x over x squared with respect to x. There's 2 questions I really want you to be asking yourself with all the tricks. Number 1, is this legal?
Yes.
Is it legal to go from 1 fraction to 2 fractions this way?
Yes.
Absolutely. Second question is, did it make your life better? If it didn't make your life better, don't do it. Does this make your life better? Does this open the door to new stuff? You'll see something new you could do now. Just Giselle. Giselle, what do you say?
I was thinking, like, couldn't you factor an x out too?
Tell me
I
more
was
about
thinking
that.
of something else. If you took out an x on the top, couldn't you like take out?
Are you looking at the first fraction or the second fraction?
I guess you could do it to both. Oh wait, what?
Okay,
Yeah.
we've got x squared over x squared. What do you know?
They have common denominator.
Yeah.
Well, they have a
Yes,
common
sir.
denominator because they came from 1 fraction, right? We're
Yeah.
taking advantage of this and saying, let me break it into 2.
Mhm.
But the reason is there's something now that you can do that you couldn't do before. What do you see? Isn't this 1?
Yes.
X squared over x squared is 1.
1.
Plus, what about over here? That's really just 4 over x. I don't know about you, but that's already a little bit better. A little more likely that I can find the antiderivative. Okay? Now, one of the other things that we can do with integrals, the really nice thing that we can do, is that you can distribute, right? We've talked about taking the integral and you can distribute if it's just addition. You're basically saying, let me break this into 2 parts. The antiderivative of 1 with respect to x plus the antiderivative of 4 over x with respect to x. I'm going to integrate this piece. I'm going to integrate this piece. I'm going to add them together. Now I know some of you guys, you know right away what this is. Antiderivative of 1,
X.
right? What function has 1 as its derivative?
X.
And I bet some of you look at this and you know exactly what it is. It's going to involve a natural log. Maybe the 4 is messing you up a little bit.
Oh, before natural
But
log.
what do you know about the 4 anchor?
It goes before the natural log.
Why?
Uh,
What do you know about 4? 4 is a
X of 1.
4 is a constant. And one of the properties that we had with the definite integral, or with definite and indefinite integrals, you can factor the 4 out. So it's 4 times the integral of 1 over x with respect to x. Why that's better, you guys all know what the antiderivative of 1 over x is.
Natural log
This has to be
of the absolute value of
natural
x.
log. So x plus 4, natural log of x plus Charlie. Bada boom, bada ding. Final answer. Multiplication and division are always going to be bad news, so you're going to look for legal algebra tricks. Show me what you guys can do at number 3. I have faith in you. You're going to find it. That's over here. There you go. Man, I'm so organized. I know your system. Multiplication and division, always the bad news. All right. Looks like we're off to a good start on this one. I can make this e to the x plus e to the next times e to the x plus e to the negative x with respect to x. I've got multiplication. Whole lot of folks doing the box. Right, and if you need to do the box, and I think the older I get, the more I rely on the box. E to the x, e to the negative x, e to the x, e to the negative x, e to the x times e to the x, e to the 2x, e to the x, e to the negative x, e to the 0, e to the 0, e to the negative 2x,
What if x equals 2?
e to the x times e to the negative x. The exponent rule here,
Oh, they add.
your bases are the same. So add the exponents. And you get e to the 0, but even better, e to the 0 is really? 1. So 1 and 1. So that means over here I've got e to the 2x plus 2 plus e to the negative 2x dx. If you're feeling really good with the integration, you know how to integrate e to the 2x. And you know how to integrate 2. And you know how to integrate e to the negative 2x. If you're not so sure, maybe breaking it up and say e to the 2x, let me integrate that, plus let me integrate 2, plus let me integrate e to the negative 2x. Right, do it one at a time if you want to. Antiderivative e to the 2x, David, what do you got for me?
Oh, you're so it's like 1/2
1/2.
e to the 2x squared.
Oh,
Wait,
wait.
do it.
Okay, 1/2 e to the 2x plus, Noemi, how do you feel about the antiderivative of 2? 2x. And Christian, how do you feel about the antiderivative of e to the negative 2x?
Plus negative 1/2 e to the negative 2x.
Negative 1/2 e to the negative 2x plus Charlie. Don't forget Charlie. Like it, love it. How many guys honestly have that as your answer? We're in a good place. The stuff that we're doing now is the foundation for the next 3 months. All the stuff we're going to do involves integration. Just like there once was a time where we worked really hard to figure out derivative rules, now it's all the integrals. All right, some of you guys can do it number 5. If you're really hungry for a challenge, go for number 6. I don't think we did number 6.
Oh, no, no.
We did number 4.
Oh,
So try number 5. Looking for clever stuff here with number 5. Multiplication and division are always bad news. Always, always, always. Anybody willing to offer up one hint, not the answer, one hint that you think would be helpful? No one wants to offer up any hints. Marvin, what's your one hint?
We already found one for 4x 2 columns ago.
Okay, so it sounds like your hint is memorize all the problems you've ever done. Good luck. Okay, maybe that's it. Jasmine, what's your hint? Think about what 4 over x really is. Okay, I like that. Noemi, what was your hint?
It was the same thing.
It's gonna be the same thing. Nora, what's your hint?
Mine was the answer to it.
Yours isn't the hint, it is the final answer. My thought is, I've got an integral sign, and I've got a fraction plus a fraction plus a fraction. Maybe do like each one separately. Not saying that you have to. How many of you guys are doing it that way? You're doing like one at a time. What you're doing is you're saying, oh, this is x over 4 with respect to x, plus the integral of 4 over x with respect to x, plus the integral of 4 over x squared with respect to x. Great. Legal? Legal when it comes to addition to distribute. Other legal things that we can do now. What are the other legal things? Edgar, what else?
For the second and third one, we can bring down the 4 because it's like,
Wait, bring down?
oh, well, but it multiplied times 4.
Right, you're factoring it out in front of the integral. And the reason that you can do that is
It's a constant.
it's a constant. Good. Okay, so we've got the integral of x over 4 with respect to x plus 4 times the
I'm
integral
trying
of 1 over x. Gosh, I love that because that's one that I've got memorized. Plus 4 times the integral of 1 over x squared. Love that. I got that one memorized. How about x over 4? Last class we struggled with this for a while. Noemi, you see it. Adriana, you see it. Nora sees it. X over 4. What's going on here, Adriana? What do you want to do?
I think you can separate it to 1/4 times x.
Is x over 4 the same thing as 1/4 times x? And that's better because
1/4 is a constant.
1/4 is the constant, so that 1/4 comes outside. So what I really have now is you've got 1/4 times the integral of x with respect to x plus 4 times, everybody can tell me this, antiderivative of 1 over x is?
Natural
Oh my gosh, 21 people know that the antiderivative of 1 over x is? Actually, the natural log of the absolute value of x plus 4 times the antiderivative of 1 over x squared. Be careful, think about it before you say it. You're going to embarrass yourself on film forever. The antiderivative of 1 over x squared is?
Negative 1 over x plus c.
Negative
I heard a clear
4x.
answer here, a clear answer over here. Noemi was like, antiderivative 1 over x squared. Be careful, go back to that chart. This is one you have to have on lock, Daisy.
Negative 1 over x plus c.
Negative 1 over x. So this is really negative 1 over x, and of course we want plus Charlie. Now before you're like, Coach, I'm done, I'm happy. No. Abraham, why are we not done? Well, maybe there's some simplifying, but there's still some calculus that we didn't do. There's a step of calculus that we're missing here. Jose, do you see what we're missing?
There's the indefinite thing in there.
Right, we still have the indefinite thing. The indefinite integral, you said, yes. Okay, the indefinite integral of x. What is the indefinite integral of x?
1/2 x.
If you need to, think of it as x to the 1 power. So this is 1/4 times a half x squared plus 4 times the natural log of x minus 4 over x plus Charlie. I like it. If you want to simplify it more, 4 times a half is 1/8. Great, love it. For folks that went solo, how'd you do? A couple of folks went solo. Good. All right, I want to take a little brain break from the indefinite integral. It is time to push, but let's grab the calculator. Let's bring out the old friend. I have good news for you. The rest of today, and I think the first 2 days next week, is all going to be about the definite integral. And here's the good news. You guys already know a lot about the definite integral. So if you look at like problem number 1 or problem number 2 down here, Ranbir, what's your thoughts? How are you going to find the definite integral?
You can separate.
Well, hold on. The definite integral. What are you going to do to find the definite integral?
Oh, you're gonna plug it into your calculator.
You're going to plug it into the calculator. Your calculator's going to do the heavy lifting. And you're like, done. Loved those days. Good. Let's enjoy that for a moment. So take out the calculator. Make sure you can get the right answer. And then it's time to grow your brain cells.
First place gets a B.
Sure, we'll give him one of yours. You're always so giving, I appreciate it.
No teachers and no kids.
God, if I had a
Y'all
heart, it
should
would
just
be
give
great.
like free huggies. I don't know why y'all stop.
Thank you for your opinion.
I usually take it home. Can you pursue? I want to see why that's on the
Jonathan, you said you want to leave.
Wait, you're taking out first. Can you take out?
Okay, so definite integral from -1 to 2 of 3x squared minus 2x plus 1. What are we getting?
9.
Should be 9. Should be 9. If you're getting 9, you and your calculator have a fabulous relationship. And go for the second one, 'cause I want both. The integral from 1 to 8 of 1 over the cube root of x plus the cube root of x. Tell you the answer to number 1 is 9. It is 9.
You want to do it? You want to do it?
So on
Did you need to your calculator?
Found it done?
Okay, if you're not sure where it is, try the templates button. Right, it's probably finding the cube root of x that's going to be a little tricky. If all goes well, 7, not 7, not for the second one.
15.75.
It should be 15.75. The first one is 9. The second one is 15.75. Okay, now here's the thing. For the rest of this period and on tonight's homework, you are free to use your calculator to breathe, to check your final answer. And you're just like, oh my God, fastest homework ever! No, not yet. Because here's the goal for today. The goal for today is to actually show you how, like mathematicians, find and evaluate definite integrals without our calculators. It's just a little bit more calculus. You're going to love it. Points are going to rain down from the sky. Did you just need to pet me? Is that what it was? Okay, thank you. Okay, very awkward. So, all right, calculators away. Open up the brains. Here comes one idea. It was really weird, and now we've got it on film. Nora petting me.
You come so close to me. I feel like
All right, here's the new idea.
you have on a sweater.
The way that you find and evaluate a definite integral has to do with your favorite theorem ever, the fundamental theorem of calculus. Who can tell me what the fundamental theorem of calculus is? Fundamental theorem of calculus. You either know it, you remember it, or you know where to look. I'm going to wait till there's like 10 hands up in the air here, because I taught the heck out of the fundamental theorem of calculus. I see 1, I see 2, I see 3, I see 4. If I don't get volunteers, I'm going for victims, especially if your name is Jennifer. Love those Jennifer victims. Love those Jennifer victims. Martyr. Jennifer adjacent. Yes, Martyr. What's the fundamental theorem of calculus?
His face
It's like right there.
when he lost the
I know the equation.
Okay, somebody else, because we're losing time here. Noemi, what's fundamental theorem of calculus?
The final value
The final
equals the initial value
equals the initial.
plus the definite integral.
Oh, I thought you were going to go even easier. Final equals initial plus the total change. Right, those were like the words. That then there's a formula that I thought Martyr knew. And now we've discovered Martyr needs to get his vision checked. The fundamental theorem of calculus is what? What's the equation? Oh, so sad. Oh, so sad. I'm going to take that down. Juan, what's the fundamental theorem of calculus?
Definite integral from A to B.
The definite integral from A to B.
F prime of x
Yeah.
dx equals f of b minus
Okay, or the way I taught you guys was f of b equals f of a plus the definite integral from a to b.
Yeah.
What you're reading is what's up there. You're right. Okay? F of b is the final. It's the final value. F of a,
The initial.
the initial. The integral from a to b. F prime is the change, right? F prime is how fast f changes, so the definite integral is, if f prime is how fast f changes, then the definite integral is how much it changes. The final equals the initial plus the total change. This is it. This is how it works. So, this guy here is the key. But I want to write it a slightly different way. The fundamental theorem of calculus connects a function. So here's your function with the derivative, with its derivative. I want to write it this way. I'm going to say the integral from a to b of f of x dx. This is the derivative of something. The thing it's the derivative of is big F, the antiderivative. So big F of b equals big F of a plus your definite integral from a to b of little f. Antiderivative, antiderivative, regular function. So just some vocab here. You get your antiderivative. This guy over here is your function. Integral from a to b, we know, is the definite integral. Okay, we're almost done, and then the exciting stuff happens. What we're going to want is I want to find the definite integral. All the problems I'm going to give you, the application problems are going to be find the definite integral. So I'm going to rewrite the fundamental theorem of calculus and say, if this is true, then this is also true. And Juan, this is what you were reading. That the integral from a to b of little f of x is just big F of b minus big F of a. Big F of b equals that big F of a plus the definite integral. So in the problems where I want this part, just subtract big F of a to the other side. Kind of okay? It's going to start popping in just a second, so things are good. There's one notation that I want you to know that kind of is like an intermediate step. This big F of b minus big F of a shows up a lot. So my mathematician friends and I like to write it this way. It's big F of x with this big vertical bar, which you guys know means, this means
Absolute value.
not absolute value. I have to have two.
Yeah.
It means at. We are evaluating big F at x equals a and x equals b. This just means evaluate at. But up until today, whenever we've done the vertical bar, it's like evaluate at one point. Now what we're saying is evaluate at the top number, evaluate at the bottom, subtract the 2. All right, let's just jump into it. So I want to find the definite integral from -1 to 2 of 3x squared minus 2x plus 1. Follow the fundamental theorem of calculus. The fundamental theorem of calculus says, go find the antiderivative. Anybody know the function that has 3x squared minus 2x plus 1 as its derivative? What has this as its derivative, Jose?
What?
What has 3x squared minus 2x plus 1 as its derivative? What you're saying is 100% right.
1/3 x cubed.
Oh!
No.
3x squared. What would have 3x squared as its derivative? Not 1/3 x cubed, just x cubed.
X cubed.
Just x cubed. Minus what has 2x as its derivative?
X squared.
X squared. Plus what has 1 as its derivative? 1x. Is that the antiderivative?
Yeah.
No.
Plus Charlie.
Plus Charlie. Okay? The fundamental theorem of calculus says if you want the definite integral, find the antiderivative, evaluate at your endpoints. Evaluate at -1 and evaluate at 2. Evaluate just means plug in. So, plug in. Plug in the 2 first. 2 cubed minus 2 squared plus 2 plus c. All that minus, we need parentheses here. I need -1 cubed minus -1 squared plus -1 plus c. Have faith, we're almost there. 2 cubed, 8. 2 squared is 4, plus 2 plus c, minus -1 cubed, -1, minus 1, plus a -1, plus c. Almost done. 8 minus 4 is 4, plus 2 is 6,
6
plus c, don't say 6c.
6 plus c.
6 plus C.
Because whoever your Algebra 1 teacher is right now threw up and they don't know why. 8 minus 4 is 4, plus 2 is 6, this is 6, plus c.
That's Henry.
Minus. Focus. -1 minus 1 is -2, plus a -1 is -3, plus c. We're there. Hold on, Jasmine. 6 plus c minus -3 plus c. Maybe you want to distribute that negative through. So minus a -3 is the same as plus 3. 6 plus 3? 9. C minus c? 0. They cancel out. And for those of you that just love it when things like this happen, what your calculator did to get the 9 is what you now are able to do without the calculator. Life is wonderful. Questions before you guys try a second one? Jasmine.
Why did you subtract in between the two? The
Here?
Yeah, how do you?
So the original fundamental theorem of calculus says that the final equals the initial plus the total change, right? But what we're really going after is the total change part. So I find the antiderivative at the end point, I find the antiderivative at the start, and I subtract those two from each other.
The equation on the right.
That's where got me the equation on the right, and so we're just like putting that process into action.
Okay.
Good question. Other questions? Everybody all right? So the key is find the antiderivative, evaluate, subtract, simplify, done. Okay, take a minute, show me what you can do with this next one. Yes, the answer will be 15.75. I want the calculus.
Oh, what did you just do?
How's the camera going? Okay.
No. Because this one has a 2. What if it's just this?
Okay. I will tell you, this does not involve the natural log. Nope. Nope. Anybody like one hint?
Is it like number 3 in the one from
I don't know. I'm not memorizing my way through the class.
It's like number 4.
I would rewrite the problem. Get rid of the radicals. Okay, so rather than cube root of x, this is really x to the 1/3. Alright, so rather than 1 over x to the 1/3, this is really x to the negative 1/3 plus x to the 1/3 dx. And this does show up in that table. Right, this is that power rule. That's the very first one. This is the antiderivative of x to the n. Mariah, how does that work? How do you find the antiderivative of x to the n?
Wait. Hold on. Is
Give her a second. Antiderivative of x to a power, what do you do?
is 1/3. Oh, you're gonna use this.
Okay, but if it's x to the n, yeah,
1/n plus 1.
you're gonna add 1 to the power, and you're gonna divide by the new power. Daisy, is that what you were gonna tell us? Add 1 to the power, divide by the new power. And then plus c. Alright, so over here. This is that x to a power, except n is -1/3. And my fraction people, be careful here. Add 1 to the power. -1/3 plus 1 is 2/3. Right? And now I'm supposed to have 1 divided by 2/3, but I bet at this point, most of you guys know you don't want to write 1 over 2/3. Jonathan, what do you really want to do here?
Oh, I wanted to ask, why isn't it 0 since they both have the same basis?
They do have the same basis, but what am I doing? You're you're adding them together. I think you're thinking about when you multiply and the bases are the same. That's when you add the exponents. But I'm adding here. Right here.
Your yellow chart says if x to the n, then y prime equals nx.
You're right. My yellow sheet, which has all the derivative rules, says the derivative of x to the n is n times x to the n minus 1. But we're not finding derivatives, we're finding antiderivatives. You know those things that people were studying at the very beginning of class?
Yeah.
Yeah, that's what we're doing over here. So, let's back this up. We had x to the 2/3 power times 1 over 2/3. I don't want to write 1 over 2/3. 3/2. Plus this guy over here. X to the 1/3. This is same thing.
3/4.
So I'm going to add 1 to the power first. 1/3 plus 1 is 4/3. 1 over 4/3 is the same thing as 3/4. You've survived the hard part. Now evaluate from 1 to 8. And yeah, let me write that in there, plus Charlie. We'll come back to that in a second. You found the antiderivative. Next move.
Plug it in.
Plug in, right? So I've got 3/2 times 8 to the 2/3 plus 3/4 times 8 to the 4/3 plus Charlie minus 3/2 times 1 to the 2/3 plus 3/4 times 1 to the 4/3 plus Charlie. I can feel the just right question out there. Somebody wants to ask it.
Do you have to
Do you have to
finish it?
Do you have to finish it? Do you have to simplify?
Yeah.
And the answer is
No.
No, it's free
It's
response.
it depends. It depends. If what we're talking about is the free response section, you're done, and I would encourage you to stop. But for right now, we are going to focus on simplifying. We're going to go multiple choice. Okay? And here's why, because this is where you guys need to practice. Okay, 8 to the 2/3 power. For those of you that sit close enough to the exponent poster, you know that when I say 8 to the 2/3, what I'm asking first is what's the cube root of 8?
2.
And the cube root of 8, everybody knows, is 2. And then this 2 up here tells you,
Multiplied by 2. Squared.
not multiplied by 2,
Square.
squared. Cube root of 8 is 2. 2 squared is
4.
4. 3/2 of 4 is 6. Plus, let's do it again. 8 to the 4/3. Cube root of 8? 2. 2 to the 4?
16.
Funny. Cube root of 8 is 2. 2 to the 4th. 2 times 2 times 2 times 2 is
16.
16. Yes. 3/4 of 16 is 12. Plus C minus 1 to the 2/3 power. Cube root of 1 is.
One.
1 is 1.
1.
Thank you for saying that with confidence. The cube root of 1 is 1. 1 squared is 1. Why did we waste our time? 1 to the 2/3 power is 1 times 3/2 plus 1 to the 4/3 power. Save me.
1.
1. David, you okay back there? Okay, looks like you're going deep with the thoughts here. You've got 6 plus 12, hey, that's 18, plus C minus 3 halves plus 3 fourths. 3 halves, 3 fourths, common denominator, fourths. 6 fourths, and 3 fourths is 9 fourths, plus C. You know the last thing that you need to do? Subtract.
Oh, the C's.
And what happens with the C's?
They can't.
They cancel. They cancel over here, right? Where else did they cancel? They cancel here at the very end.
Before that.
They canceled, I could have canceled them here.
Before that.
I could have canceled them here. So usually mathematicians don't even bother when it comes to definite integrals because they cancel. Okay? Last thing, 18 minus 9 fourths?
The last one.
15.75.
Good guess.
15 and 1/4. 15 and 3/4.
This is really 18 minus 9 fourths, 18 over 1. I need common denominator, fourths.
She's so
72 over 4 minus 9 over 4. 63 over 4. 63 over 4. 15.75. Yes, it's magic. So, for those of you keeping track of the points, you get the first point when you find the antiderivative. You get the next point when you plug in the limits. And the third point comes in from being able to simplify. Show me what you can do from here. You got almost 10 minutes, plenty of time.
chill down.
That paper. That's the back.
Good question, Rombeer. Which one? Derivative or antiderivative here? Antiderivative.
Is it okay if we change that?
And Rombeer, that is conflict that should be happening in your brain right now. We've been in derivative mode for like half a year. Nice. 1, 2, 3, 4, 5, 6, 7 folks. I already got the first part done.
So we just that's how we get to equate the
So antiderivative sine theta, negative cosine theta. Just quick show of hands. How many of you guys have negative cosine theta plus 1/2 sine 2 theta as your antiderivative? Nice, good news. Honestly, if I'm scoring free response, that's where you get the first point.
Even without Charlie?
Because we're doing a definite integral,
Yeah.
it cancels out. Okay? So your first move, you found the antiderivative, you're pretty much done with the calculus. Truly, you're done with the calculus. Jose, what's next? You're going to plug in what? You're going to plug in the endpoints. Which one goes in first? Which one goes in first?
Pi over 2.
The top one. Here comes the next point. If you get this right, negative cosine pi over 2 plus 1/2 of sine 2 times pi over 2. All that minus negative cosine 0 plus 1/2 the sine of 2 times 0. Hold on, Mariah. It's all of what you get from plugging in the top minus all of what you get from plugging in the bottom. And good news, even before you simplify, I'm ready to give you the second point. Yes. Because now it's just, can you simplify? And if we're talking free response, you don't go any further. But let's spend the time on the trig skills. For those of you that need a little bit of a push, maybe you want to go back to your unit circle. For every angle on the unit circle, the x is the cosine, the y is the sine. What's up, Romeo?
It's
The square root. With the square root.
Pi?
Okay. No, it's a check mark. It's a check mark.
Oh, the square root?
Oh yeah. Okay, but the square root, but with the 3.
No, there's not going to be any.
Square root
No,
of 3
it's,
over 2.
No, you
No,
just keep
no,
going.
it's 3 over 2, so it's gonna be 0.
Pi over 2, you're up here. The cosine of pi over 2 right over here is 0. 0 plus a half. 2 times pi over 2
2 pi over 2.
is not 2 pi, but it's 2 pi over 2, which is pi. Pi. What's the sign? The sign is the y value.
1.
It's not -1, it's the
One.
y value. It's
One.
the height. 0
Oh, 0.
minus
What?
cosine of 0. Here's my angle. Cosine is the x value. The cosine is the x. So it's -1 plus 2 times 0 is 0, sine of 0. Here's my 0-degree angle. The y value is 0. Okay, so what is that? 0 minus -1, positive 1. Keep going. If you're really looking for a challenge, try number 5. If you're not ready for that level of challenge, do number 4.
Just 1/2 e to the 2x. Then it's negative e. No, 1/2. Negative 1/2.
Okay, for the folks that are on number 4, hopefully you're done with the antiderivative part. The antiderivative is just 1/2 e to the 2x minus 1/2 e to the -2x from -1 to 1. How many of you guys have that as your antiderivative? Good. There's a reason I want you to have those 13 forms just popping. So you get the first point. Jose, what's your next move?
You plug in the top one.
Okay, so let's do that. Plug in the 1. You're going to get 1/2 of e squared minus 1/2 e to the, what is that? -2. Big parentheses, minus all the stuff after it is 1/2 e to the -2 minus 1/2 e squared. And I hear a whole lot of whispering about it's 0, it's 0. No, it's not.
It's a positive.
Okay, here's the good news. 1 point for finding the antiderivative, 1 point for knowing to plug in. If the simplifying doesn't go so well for you, okay, we're going to work on this. Just give me 1 second to finish this off. I'm going to distribute the -3. So you've got 1/2 e squared minus 1/2 e to the -2 minus 1/2 e to the -2 plus 1/2 e squared. There are like terms here. In the world of algebra, you call it a like term if the variable and the exponent part matches. So the only thing I can combine with this 1/2 e squared, there's only one thing up here that I can combine with it.
The one at the end.
And that's the last 1/2 of e squared. So if I have 1/2 of e squared plus another 1/2 of e squared, what is that really?
E squared.
It's e squared. And so I've taken care of this guy and this guy. Now I've got -1/2 of e to the -2 and another -1/2 of e to the -2. And what is that really?
Negative
It's
e to
negative,
the
right? Some of you are like
power
-2/2 e to the -2. Sure, but it's really negative e to the -2. And do not combine these. They're not like terms. The variable and the exponent part would have to match. Okay? And maybe what I would do, because I'm just mean and evil, I might write the final answer as e squared minus 1 over e squared in multiple choice. But I bet that wouldn't catch many of you guys. Okay? Okay, so tonight's homework, the last page, there's 10 problems. Giselle, you're wonderful. Thank you for all that. If you